Welcome to this video on using contingency tables. After watching this video, you will be able to define contingency table or two-way table, use a contingency table to answer questions about probability, and use Microsoft Excel to generate subtotals and totals in a contingency table. This video assumes an understanding of the addition rule. For lessons on the addition rule, please watch my videos entitled Addition Rule for Disjoint Events and the General Addition Rule. This video also assumes a basic understanding of probability, so watch my video entitled Basic Probability for an explanation of the basic concepts of probability. What is a contingency table? A contingency table or a two-way table relates two categories of data. A contingency table has a row variable, a column variable, and a collection of cells. Here we see the marital status of males and females 15 years old or older in the United States in 2013. Can you identify the row variable? The row variable is the marital status. The possible values of this variable are never married, married, widowed, divorced, and separated. Note that those are the possible values of the variable, not the variables themselves. Can you find the column variable? The column variable is the gender of people. In this example, the two possible values are male and female. Note that male and female are not themselves the variable, but the possible values of the variable. Lastly, the cells are the values or counts in the contingency table. Example 1. Determine the probability that a randomly selected U.S. resident 15 years old or older is male. So again, we will be using this table. In order to calculate any sort of probability, we need to find subtotals and totals for this table. You can do this manually or by entering the contingency table into Microsoft Excel. Here, as you can see, we have a new row and a new column. If you would like to learn how to use Microsoft Excel to generate these totals, stay tuned till the end of the video to learn how to do this. So notice we have this new row at the bottom of our table. So what we've done is we've added all the males together to get 122, and then we've also added all the females together to get 128.8. Likewise, we have a new column in which we added, for example, all of the never married people together to get the total number of never married people, and then we added all the married people together to get a subtotal for the married group, and so on and so forth. So again, this is the total number of males, total number of females, total number of people who are never married, total number of people who are married, total number of widowed people, divorced people, separated people, and last but not least, the grand total. So this is like all of the people or individuals who are represented in this table. And that's going to be important because we're going to use that number a lot. So the question that we're asked again is, what is the probability that a person is male? This is a simple probability question. So in order to answer it, all we need to do is figure out the number of males, which is 122.5 million. And then we need to divide that by the total number of people surveyed, which in this case was 151.3 million. Doing that, we find that about half of the population is male, which is what you would expect. Example 2. Determine the probability that a randomly selected U.S. resident 15 years old or older is widowed. So again, we have this table. If you'd like, you can pause the video, see if you can calculate the probability on your own, and then unpause the video to check yourself. So the probability of being widowed is just the number of people who are widowed over the total number of people surveyed. So that gives us 14.3 over 251.3, which is about 6%. Example 3. Determine the probability that a randomly selected U.S. resident 15 years old or older is widowed or divorced. The first thing we have to ask ourselves is, are the events widowed and divorced disjoint or mutually exclusive? So pause the video, think about this for a minute, and then unpause it. So in reality, it's possible for people to get married multiple times. So I could get married and then divorced. I could get remarried and then my spouse could pass away, and then I would be widowed. So we all know that it is possible for one person to be in both categories. But that's not really what we're asking. We're asking is the outcome of being both represented in this contingency table. So here is the row of people who are widowed, and here's the row of people who are divorced. Is there anywhere in this table where those two rows overlap? And the answer is no, because they're parallel, they're not overlapping. So since that is the case, there is no cell in this table that represents people who have been both widowed and divorced. We are going to treat these events as disjoint or mutually exclusive. Therefore, we can use the addition rule for disjoint events. And that says that the probability of event A or B occurring is the probability of event A plus the probability of event B. Putting that into the context of our problem, we find that the probability of being either widowed or divorced is the probability of being widowed plus the probability of being divorced. The probability of being widowed is 14 over the total number of people surveyed, which is 251.3, plus the probability of being divorced, which is 25.4 over 251.3, and that gives us 39.7 over 251.3, which is about 16%. Example 4, Method 1. Determine the probability that a randomly selected U.S. resident 15 years old or older is either female or separated. Ask yourself the question, are the events female and separated mutually exclusive or disjoint? Pause the video, write down your answer, and then unpause it to see if you are correct. Here are the females, here are the people who are separated. Do these categories overlap? The answer is yes, they overlap right here. There are, according to this chart, 3.2 million people who are both female and separated. So that means that we can't use the addition rule for disjoint events. We have to use the general addition rule, which says that the probability of event A or event B occurring is equal to the probability of A plus the probability of B minus the probability that A and B both occurred at the same time. Putting that into the context of the problem, we see that that means that the probability of being either female or separated is equal to the probability of being a female plus the probability of being separated minus the probability of being a separated female. So we have 128.8, because that's the total number of females, over 251.3, that's the total number of people represented by the table. Then we have 5.6, that's the total number of separated people, over 251.3. And then we need to subtract off this crossover, this pink cell right here, which is 3.2 over 251.3. Doing that math, we get 131.2 over 251.3, which is about 52%. Example 4, Method 2. Can you think of a different way of solving this problem without using the formula we used in the last problem? Pause the video, write down your thoughts, and then unpause it. So another way to approach this problem is to simply add together all of the cells that meet the requirement female or separated. Let's try to look at the table and see if we can find those cells. So all of these cells here represent people who are female. Are there any other cells that meet the requirement female or separated? We also need to include this cell here because somebody could be separated even though they're not a female. So we need to include the number of males who are separated. Since the female column has already been summed up for us, instead of adding all of these 5 cells together, we could take a shortcut and just use the sum, which is 128.8. So then all we have to do is add 2.4 and 128.8 to get a total of 131.2, which is the same numerator we had from the last problem. Then of course we just divide that by the 251.3, which is the total number of people on the table, and we get the same answer as last time, 52%. So either of these approaches is a valid method to calculate the probability. Example 5, Method 1. Determine the probability that a randomly selected U.S. resident 15 years old or older is male or never married. We need to ask ourselves the question, are the events male and never married, mutually exclusive, or disjoint? Pause the video, write down your answer, and then unpause it. Here's the event male, here's the event never married. Notice that they overlap in the middle, and there are 41.6 million people who are both male and never married. Since they are not mutually exclusive, we have to use the general addition rule. So that states that the probability of A or B is equal to the probability of A plus the probability of B minus the probability that both A and B occur. Putting that into the context of the problem, we see that the probability of either being male or never married is equal to the probability of male plus the probability of never married minus the probability that you are a never married person who is also a male. So we can calculate these probabilities as follows. The total number of males is 122.5. And again, we're always dividing by the total number of people represented in this table, which is 251.3. The number of people who are never married, according to this table, is 78.5 million. And then the number of people who are both male and never married, which is this pink cell right here, is 41.6. Remember, we have to subtract off this third probability because we actually counted it twice. We counted it in both of these probabilities here. That gives us a fraction of 159.4 over 251.3, which is about 63%. Can you think of another way to do this problem? Pause the video, write down your answer, and then unpause it. So another way to approach this problem is to simply add together all of the cells that meet the requirement male or never married. So all these cells represent people who are males, plus this cell right here represents people who are never married. Since the male column has already been summed for us, we can simply use the total number of males, 122.5, and then add to that the number of females who were never married. Doing this, we get 159.4 over 251.3, which again gives us the same exact answer we got using the last method, which is 63%. Using Microsoft Excel to generate subtotals and totals in a contingency table. If you would like to know how to get from this contingency table right here to the contingency table that has all of these subtotals using technology, please watch the rest of this video to find out how. If you would like to use Microsoft Excel to calculate your totals and subtotals, the first thing you have to do is recreate the contingency table in Excel. Notice that I've already done that here. So let's start by summing our columns. I'm going to left click with the mouse on this first cell. I'm going to hold down that button and drag all the way down to the bottom of that column. Then, making sure you're in the Home tab, go over to AutoSum and click the button. We're going to do the same thing for this column. Left click on the mouse, drag it all the way down, click on AutoSum. So I'm going to label this subtotal, and I'm going to create borders around it. Now I'm going to create a new column that's also called subtotal. And now what I need to do is I need to sum my rows. So I'm going to highlight these two cells, again, go up to AutoSum and click that button. Now you could do this a bunch of times for all of those rows. An easier way of doing it is clicking on the cell. Notice right now that my cursor looks like a larger white cross. If I come down here, it becomes a smaller black cross or crosshair. And when that symbol appears, I can click with my left mouse button and hold that button down and then drag all the way down. When I let go, notice that all of those sums appear. That's the fastest way that I know of to sum your values. So you might argue that entering in your contingency table is going to take a lot of time, especially since anytime you're doing data entry, you always have to double or triple check the values you typed in. While that is true, I feel like the time you spend typing in those values into Excel is more than compensated for by the ease in which you can calculate your subtotals and totals. But again, it's up to you. You can always just use a calculator. Having watched this video, you should now be able to define contingency table or two-way table, use the contingency table to answer questions about probability, and use Microsoft Excel to generate subtotals and totals in a contingency table.